Hi my scholars, this is my school channel and my name is Abiola. For this video lesson, we'll be solving the JAMB CBT past question for the subject physics. For the year 2010, do not go anywhere, stay with us and we'll be right back. Welcome back to my school YouTube channel. Right there we are going to solve questions 21 to 35. So let's start with question 21. In comparing the camera and the human eye, the film of the camera functions as the retina. Okay, so when it comes to the light sensitive area, you're talking about area that is concerned with image formation. This is where we point to. So looking at the iris and the diaphragm, right there we are talking about control of the amount of light that comes in. Then when it comes to the pupil, right, and the aperture, that is how light enters. Then another similarity is about the converging lenses that are present in both the camera and the human eye. All right, so they help to, when it comes to focusing of light, I give it to the converging lenses. So the correct option here is option A. The retina and the film, they perform similar functions. So option A is the correct option. Question 22. An object 4 cm high is placed 15 cm from a concave mirror of focal length 5 cm. Now the size of the image is what? Alright, so we should know that depending on the sign convention we want to follow, either we want to follow real positive or the new Cartesian. Alright, so if I'm going to work, let me say I'm working with the new Cartesian. Alright, so right there, I should have my focal length should have a negative value. So that is -5. Okay, then as well, my objects, okay, for my object of distance, that should have a negative value as well. Do you see that? Now then I look for my V at first, the image distance, okay? But if I don't want to work with this, if I want to work with my real is positive, so I will just take everything as positive. That means here will just be 15 and here will just be 5 as well. So whatever method you use, you should still arrive at the same answer for the value of your image height. Okay, so let me just work with this. Really is positive. Okay, so I have this. Remember the length formula of the mirror equation, which is 1 over V plus 1 over U equals 1 over F. Some presentation can start with 1 over F equals 1 over V plus 1 over U. We are still doing the same thing. All right, so what do I have to do? I have to send this to the right hand side, right? So I have 1 over V equals 1 over F, right, minus 1 over U, and that implies that 1 over V equals 1 over F, my F is 5, right, minus my U, that is 1 over 15. So the LCM right there is 15. 5 in 15, that goes 3 times 1. I have my 3 minus 5 in 15. 15 in 15, that is 1. Times 1, I have 1. So here I have 2 over 15. So we can see that 1 over V equals 2 over 15, right? If I cross multiply, that is 15 times 1 equals 2 times V. So we are not looking for 2V, right? We are looking for V. So what do? I divide both sides by 2. This implies that V equals 15 over 2. So remember your magnification equation to put. Okay, so your image distance over object distance equals image height over object height. So I can just use this, right? Okay, so this is my image distance, my object distance, my image height, my object height. So we are asked to look for the size of the image, which is this. Okay, so if we cross multiply again, so I should have my image height times object distance, right, equals this times this. My image distance times object height. Okay, so dividing both sides by U, which is the object distance, then that means the size of my image, right, should mean this, which is V, which I've gotten as 15 over 2. Of course, you can use your calculator to go through all of this. You can even write this as 7.5. All right, so times, right, my image, the height of my object, which is given as 4, an object 4 centimeter high. Do you see that? So that is times 4 over 1. Then we have all over, which is divided by my u. Okay, my u is 15 divided by 15 over 1. So if I want to convert this divide to times, okay, this will have to come up, this will have to go down. Okay, so I will just have times 1, right, over 15. So you can see 15 here 1, 15 here 1, 2 here 1, 2 here 2. So I can see that right here, my image height is 2 centimeter. So let's just go back to the screen and see if we can fetch out 2 centimeter. Very well, that is available in option A. So option A is the right option. Question 23. An object is embedded in a block of ice, okay, 10 centimeter below the surface. Now, if the refractive index of the ice is 1.50, remember, no units, okay, the apparent depth below the surface is what? So you can just use this simple formula: refractive index equals real, okay, over apparent, real depth over apparent depth. So I just have my refractive index, I can use n to represent it, okay, equals my real depth, my real over apparent. Let me just use this symbol, letters to represent them. So right there, I'm asked to look for my apparent depth. So if I cross multiply, I have A times N equals R. So I'm looking for A, I divide both sides by N. So that implies that A equals this, right? So I should have my A equals, right, my real depth is given as what? You can see from what we have here is 10 centimeter below the plane surface. So I have 10, right, over my refractive index, that is 1.50. Okay, 1.5 or 1.50. So since I'm working without a calculator, I can decide, just punch your calculator, you should get your answer. But I want to see I can do this without using a calculator as well. So I know that 1.5 actually means 15 over 10. Okay, so if you look at this, this means 15 over 10. If I simplify further, this is 5 goes here 3, 5 goes here 2. So this actually means 3 over 2. So this implies that 10 over 1, right, divided by 3 over 2, that means 10 over 1 times 2 over 3, right? So I should have this times this, that is 20 over 3. And 20 over 3 is 6.66666. I cannot say 6.7 or 6.67. So let's see if I can produce that same answer on the screen. Remember your unit, centimeter. Okay, so where do I have that? Yeah, that is found in option B. So option B is the valid option. 24. Which of the following is used for the correction of short-sightedness? All right, this can be referred to as myopia. You know, such people with that kind of eye defect, you know, they can't see distant objects clearly. All right, so in that case, what you need is you need a concave lens or a diverging lens. Okay, so this is because, you know, it can be that the eyeball is too long, all right, or the converging power or value is just too much. Okay, so what you just need is to diverge. All right, and in this condition, what is happening is that the whole image formation is brought in front of the retina, not on the retina. Okay, so you can see where the issue is coming from. So when it now comes to the other part or the opposite side of this, which is long-sightedness, you know, those people, they can see distant objects, or very close ones, they can't see them. All right, so what you need in that case, we are talking about convex lens. All right, this may be because the eyeball, right, is too short. So whatever image that is going to be formed goes behind the retina. All right, so what you need is something that will bring the rays together, the image to be formed together on the retina. So you can see that as well. So we are talking about this. So we are talking about convex lens or converging lens. Okay, so we've settled this. So this is for long-sightedness. This is for short-sightedness, their correction. Okay, so when we talk about concave mirror, no, concave mirror, they are excellent shaving mirrors like I mentioned earlier. So when you are driving, this is what you see most times on your side mirror. So the correct option is option B for concave lens. Question 25. So dispersion occurs when white light, right, passes through a glass prism because of the what? All right, so you know this is a phenomenon whereby white light, okay, it's separated into its component colors, right? And that is roic beef. Your red, your orange, your yellow, your green, your blue, your indigo, and violet. All right, and this is based on the concept of their wavelengths, you know, their different wavelengths and their frequencies. Okay, so this put together will now tell us confidently that we are talking about this dispersion because of their different speeds when it comes to medium like the glass. So I can put it this way based on the options provided, that dispersion occurs when white light, right, passes through a glass prism because of the different speeds of the color components in the glass. So option B is the correct option. Yes, we strongly recommend that you have a JAMB CBT simulated experience, okay? All you just need to do to get this wonderful experience is to click on the link in the description below. It's going to get you to the Myschool website, okay? Right there, you get to download the Myschool mobile app for your Android devices. Or you can try out our Myschool software for your laptops and your computers. So join me as we solve question 26. When a positively charged rod is brought near the cap of a positively charged electroscope, okay, the leaf's divergence will do what? Okay, so right here we are talking about the gold leaf electroscope. You know, it's used for detecting or testing small, all right, small, I can say small charges, okay, small currents or so thereabouts. All right, so let's go back to what we are given here. So when the same charge, just take note of this, when the same charge is present on the rod that is being brought near, okay, and the cap of the electroscope, what you will notice is that the divergence will increase. So that is, the divergence will diverge further. All right, so we have a positively charged rod is brought near the positively charged electroscope. Of course, the divergence will diverge further. Okay, so that is what we are looking for right there. So the correct option here is option C. And do not forget that you just have to hit the like button to encourage us. Also click on the subscribe button and always tap on that bell notification so you can get alerts immediately we put on the next video content just for you. 27. Power supply is transmitted at a very high voltage and low current in order to do what? In order to reduce power loss, okay, or energy loss in the form of heat. This is due to the electrical resistance of the power cables being used, okay, and this concept can be well related or well described as the high tension transmission. All right, so basically now what I've just said can be well packaged in option D, okay. Power supply is transmitted at a very high voltage and low current in order to prevent overheating of the coil. So the most appropriate option here is option D, to prevent overheating, you know, loss of energy or loss of power in the form of heat. So option D is the correct option. Question 28. A galvanometer with full-scale deflection of 10 milliamperes, take note of this, milli, okay, is to be converted to a voltmeter with full-scale deflection of 5 volts. All right, so if a series resistance of 498 ohms is used for the conversion, now the resistance of the galvanometer is what? All right, so when you want to convert from galvanometer to voltmeter, you use the multiplier. Okay, from galvanometer to ammeter, you're talking about the shunt. All right, so let's do this at first. Remember that we are giving your current in, you can see, I think I have here 10 milliamperes, 10 milliamperes, right? So that is 10 over 1000. Milli is 10 raised to the power minus 3, right? So I have this, so that should be 0.01 amperes. Okay, so when coming across to the PD of the galvanometer, so that is V equals IR. I believe we know that very well. So that means what we are looking at is your I, which is 0.01 times R. You know, this is the R we are looking for, the resistance of the galvanometer. All right, so take note of the second PD. Let me just label this V1, V2. So that's just the difference between this and this. Okay, so let's look at the PD of the voltmeter. The PD of the voltmeter is 5, right? Minus the PD of the galvanometer, which is this. Okay, we see that right now, right? 0.01 times R gives us this. So basically, the resistance we are now given now. So if a series resistance of 498 ohms is used now of that multiplier, so remember that resistance, okay, let me take it back from this formula just from here. You know that V equals IR, right? Therefore, R will be what? V over I. isn't it? So that is what I'm using right here. So I have V over I. Okay, so basically what we are looking for now is your R. So let's just make it happen. So what I'm going to have here now will just be, my R is given as 498, right, equals my V, okay, which I have here, which is 5 minus 0.01, the small resistance, okay, over the current that actually passed through, which is 0.01. Okay, so when I cross multiply, what I should have is 498 times this should give me 4.98 equals 5, right, minus 0.01 R. So I can decide to collect like times. So I can send this here, then send this here. So if I'm sending this to this place, it becomes positive. This becomes negative, right? So I will have 0.01 R equals 5 minus 4.98, isn't it? 0.1 R equals 5 minus this should give me 0.02. Okay, so if I divide both sides by 0.01, so basically my answer should be 2 ohms. So let me see if I have 2 ohms provided in the options, okay, on the screen. So let's move back to the screen together. Yes, I have that in option B, so option B is the right option for this question. 29. Two inductors of inductances 5, you can say milli, all right, 15 milli, all right, so are connected in series and a current of 5 amperes flows through them, all right. So the total energy stored in the inductor is what? Okay, so the total energy, you know, you can use W to represent it, your W, so equals this. You know, you're talking about the inductance, which has inductor, which has the inductance, yeah, then your current, okay, raised to power 2. So remember that this is our inductors are connected in series, right? So we just add up. That will be, yes, that will be 5 plus 15. But we are going to have them over 1,000 because we're talking about milli, right? So that is over 1,000. Okay, so that will be 20 over 1,000, isn't it? So 0 cancels 0. So I basically have 2 over 100. So my L is 2 over 100. So I can have my L as 2 over 100. Okay. All right. So let me just introduce it here. So I have the energy stored as half. Sorry, that's half, right? Half, right? Times my L, which is 2 over 100. Then times my current, okay, raised to power 2. So that is 5 times 5. You know, 5 raised to power 2 is 5 times 5, isn't it? Okay, so we are doing great. So we have this. Okay, I have 5 here 1. I have 5 in 100, that is 20 as well. Then I have 5 here 1. 5 in 20 again, that is 4. 5 in 100 is 20. 5 in 20 is 4. So for the numerator, I have 1. For the denominator, I have 4. So 1 over 4 is 0.25. Okay, if you would like to do this with me, so I have 4, I have 1. 4 in 1, that is 0. Introduce 10. 4 in 10, right? I have, it goes 2 times. 4 times 2, 8. So I drop down 2, put 0. 4 in 20, this is 5. So you can see we have joules, of course, energy, joules. So the correct option should be 0.25. So let's go and fetch that out, 0.25 joules. So where do we have that? Okay, so you can see that we don't have 0.25 joules in the option provided. So there is no correct option attached to this question. Question 30. So in alternating current circuits at resonance, okay, the angle of lead or lag is what? Now take note of this. You know, when it comes to for capacitors, right, it is the current that is leading when you compare it to the voltage. All right, so that means the leading will be by pi over 2. Okay, this is for, we are talking about radians. So I just say 90 degrees. So the current is leading by 90 degrees. Okay, so but when it comes to your inductor, all right, you are talking about inductance, inductor, that is where the voltage is leading by 90 degrees. So let me take it again. So when it comes to capacitor, the current is leading by 90 degrees. Okay, so when it comes to your inductor, your voltage is leading by 90 degrees. Now in resonance, right there, you know, the effect of their reactances, that is the inductors and the capacitors, their effect okay, we cancel each other out. That is 90 minus 90. Do you see that now? That's equal what? 0. So in alternating currents at resonance, the angle of lead or lag is what? 0 degrees. So the correct option is option D for 0 degrees. Number 31. So in a discharge tube, most of the gas is pumped out using the vacuum pump, okay, so that the electricity is conducted at low pressure and high voltage, or you can say high PD. So what do we have here? We have low pressure and we have high voltage. So the correct option here is option D for low pressure. Do not forget that you can ask your questions right now. So you may ask, how do I do this? Very easy. All you just need to do is to click on the link in the description below. This is going to get you to the Myschool website. So right there you get to ask those questions on the spot. And our solution providers are going to attend to you, of course. So join me as we solve question 32. The ground stated energy for the hydrogen atom is 5.44 times 10 raised to power minus 19 joules. Okay, so if an electron drops from 0 energy to ground state, okay, calculate the frequency of the emitted radiation. So we're just going to use E equals to HF, where H is your Planck's constant and your F is your frequency. So we are asked to look for frequency right here. So we have our E as 5 points. Okay, let me just pull out the formula. So we have our E as 5.44 times 10 raised to power minus 19, please. Okay, then we have our Planck's. So normally we are looking for F, frequency. So what we should have will be frequency equals the E, right, over H. Okay, so that means this value over H equals F. Okay, so I have my Planck's constant, that should be 6.6, yeah, 6.6 times 10 raised to power minus 34. Okay, so if I want to solve this using standard form, all right, so I will just say 5.44 over 6.6, right, times 10 raised to power minus 19. You know, I have 10, I have 10. This divide means minus. Minus, then this minus that we have here, minus 34. So if I divide this, I should have 0.8242424, just like that. So let's look at this part. Okay, so minus times minus, that is plus. So that should be 10 raised to power minus 19 plus 34. So it's just the same thing, saying 34 minus 19, that is 15. Okay, so I can still make this in standard form as well, as 8.2424 times 10 raised to power 14. So either I use this or this. So let me see if we have this value provided. Okay, so of course frequency is measured in hours, so we don't have such value here, so there is no correct option to this question, okay, that's at least available. So the correct option to this question will be no correct option in option E. So it is possible that you've gone through a video lesson and you have better steps or explanations or suggestions you'd like to share. Please, we are so much interested. All you just need to do is to use that comment section below. Please indicate the question number and the solutions or explanations you'd like to share. Question number 33. So transistors are used for what? You know, basically they are used as current amplifiers. So when it comes to amplifying or switching electrical signals, we are talking about transistors. Okay, so conversion of AC to DC, we can talk about your PN junction diode. Okay, they can act as rectifiers, you know, converting AC to DC. So going back to the question presented to us, transistors are used for what? Okay, they are used for the amplification of signals, electric signals to be specific. Okay, so the correct option is option C. Number 34. Which of the following is a pure semiconductor? So at first, let's talk about semiconductors briefly. You know, we are talking about elements, or we are talking about substances, okay, whose resistivity, okay, it's actually in between for conductors and insulators. So, you know, and you can find them in a group 4 of the periodic table. Okay, so when you say semiconductors that are pure, All right, you are saying that they are intrinsic. Okay, they have not been doped. That means undoped. Okay, so and such are silicon and germanium, at least for this context. So for the options provided, we have silicon. So the most accurate option here will be silicon, option B. So which of the following is a pure semiconductor? Silicon is a pure semiconductor. Question 35. The diagram above shows a velocity time graph. Okay, so the statement that is true about this motion is that the car. Okay, so from E to F, you can see the acceleration is increasing. Okay, so you can see, and of course you can see that here. So I can say accelerating, decelerating. Acceleration here is 0. Velocity, there's no change in velocity right here. Okay, so you can see accelerating, constant speed, decelerating. Let's just take it that way. Accelerating, constant speed, decelerating. So here acceleration is 0. Acceleration carries negative value, and there's an action, or I can say the car is accelerating right here. So acceleration is 0. Then this is deceleration, okay, or retardation. So the diagram above shows a velocity time graph. The statement that is true about this motion is that the car has no acceleration between points F and G. That is the correct option. Look at B. Decelerates between F and H. That is incorrect. Look at F and H. All right, so there's a spot here before this spot. C has a constant speed between points E and F. Okay, so we are talking about points E and F. You can see that there is a change here. This is where we have constant speed. All right, so the car accelerates between points F and G. So right here, you can see the acceleration did not change. We have 0 here for acceleration. So the correct statement is found, option A. So is that the car has no acceleration between points F and G. So this is the end of this video lesson, but there are definitely more wonderful content to come. All we just need you to do to encourage us is to hit that like button, and do not forget to click on the subscribe button always, and tap on bell notification for you to get alerts immediately we upload the next video lesson just for you.